Okay, so how do we map? How do we map the textures UV? Okay, let's say UVN because n represents the normal with the object's tangent plane. Now, to answer this question, let's remember in computer graphics, previously we have learned about how do we convert between different coordinate systems. Okay, so let's say we have an XYZ system, okay, and an arbitrary UVW coordinate system. Okay, this could be like the world coordinate system. This could be the camera coordinate system. Okay, we have learned about such mappings before. Now, how do we map from XYZ to UVW? Okay, so these are two coordinate systems. The only thing, let's say, that you know are that is that they are each coordinate system is orthonormal. Okay, so they are unit vectors and perpendicular to each other. But other than that, their orientation is different. How do you map? Now, we know that, we have learned this before. Let's map x to u. How can I map x to u? My x vector is going to be something like this, right? 1, 0, 0. I want this vector, when multiplied by a matrix, to map to u. Right? I want this to map to u, ux, uy, uz. So the x, when multiplied by a matrix, will become u. Similarly, y, when multiplied by the same matrix, is going to become v, and z is going to become w. Now, in this matrix multiplication, we know that this 1 will get multiplied by the first column only. So this column must contain ux, uy, uz. Okay. Now, similarly, let's change this. Okay. So let's say we want to map the y to v. This is going to be 0, 1, 0. This is my y. Okay. And my v is going to be vx, vy, vz. How is it is going to happen? The second column means the second element here means the second column here is going to be vx, vy, vz. Okay. The same will apply for the third one. So this is going to be 1, and this is going to be w. Okay. And it means that this is going to be wx, wy, wz. Okay, now let's clear these parts. This matrix is a different way of writing this is this, okay? U, V, W, kind of a shorthand notation. This matrix will take you from the XYZ system to UVW system. Okay? It's a rotation matrix basically. It's going to rotate. This is going to map this system to UVW. Now we can use the same idea with texture mapping to map the tangent plane, the tangent space. Okay? So how do we do that? Let's say this is the now instead of XYZ, let me write the tangent space. In tangent space, we said that this is 1, 0. Let's pretend that this is 3D. Okay, 1, 0, 0. This is 0, 1, 0. And this is 0, 0, 1. Okay? So this space is the textures space. Okay, so this is the U direction on the texture, the V direction on the texture, and the perpendicular direction on the texture. Okay. Now, this is the space, but here in the texture space, I can have a vector indicated by the RGB value that kind of points like that. Okay. I can have a vector like that. From its RGB value, we can obtain vectors like that. Now, for the object, okay, let's draw the object again. Let's draw the cube example. Okay. Now, for this point, I have the, let's say, T, B, and N vector. Okay. So what I want to do is I want to map this space onto this space. Okay. So I want this, let's call this was U, right? This was V, and this is the, let's call this the, I don't know. Actually, let me call for the, to make the example consistent, let me call this X, let me call this Y, and let me call this Z direction, okay? Now, I want to map this onto TBN, okay? So X is going to map to T, Y is going to map to B, and Z is going to map to N, okay? And once we do that, any normal in this space, in the texture space, is going to reorient. It's going to be oriented by this matrix so that if this normal was pointing along X in the texture space, it's going to end up pointing along T in the mapped space. Okay? So map XYZ to TBN. And as we have just talked about this, the matrix that accomplishes this mapping is the TBN matrix. Okay, so this TBN matrix, when you multiply this TBN matrix, so this is a normal, right? This is a normal from the normal map. Let's call this N prime. When you multiply this with N prime, it is going to map, it's going to be reoriented, let's say rotated, so that it matches the tangent space on the surface. Okay? So then the next question we must answer is, how do we compute TBN? How do we compute these tangent, bitangent, and N vectors? Now the normal vector is, we know, is easy to compute. We have been computing for shading anyways. But we need to learn about how to compute the tangent and bitangent vectors.